So myself Shivam, and today in this video we are going to see the problem of the day. Problem name is K at distance. First, we will go through the problem statement and then we will see the test cases we have. After that, we will try to understand the approach. We will be seeing both the approaches. That is, first we will see the brute force approach to solve this question. We will discuss the time and space complexity, and then we will try to optimize this problem. And again, we will discuss the time and space complexity of that approach as well. Okay. Problem statement is given an unsorted array, also given the number k, which is smaller than the size of the array. We need to find if the array contains duplicate element within k distance. So what problem statement is stating? That we are given with an unsorted array, right? And we are also given with a number k. We need to check if the array contains any duplicate element within k range. Okay, so let's see some of the test cases to understand this in better way. So if you see, the first test case is 1, 2, 3, 4, 1, 2, 3 and 4, right? And the value of k is 3. So basically, we need to check for each and every element in the range k if any element exists which are equal to that element, right? So what I mean to say is, let's say we have this 1, right? So we will check if in our array any other element is there with the same value, that is 1. So you don't have to check the whole array. It depends on this k value. So first k value is 3, right? So first we will check 2. So we found that 2 is not equal to 1. So we can check the other element we have. Then we check 3. No, again, if you see 3 is not equal to 1, we go ahead and we check the other element we have, that is 4. Now if you see, again, this 4 is also not equal to 1. But we should not go and we should not check 1. Why we should not check 1? Because if you see, the range has been completed, right? The range was 3 only. So we need to check up to 3 element only, not more than that. So we will not check this element. So I think 1 is perfectly fine, right? And there is no duplicate element within k distance of this element 1. So we need to do the same for each and every element in our array, right? So let me erase this. Yeah. So I think 1 is okay. So now we can go ahead and we can check for 2, right? So again, we need to do the same for 2, right? So for k is equal to 1, this is k is equal to 1 for 2. We found that it is not equal to 2. K is equal to 2. No, it is not equal to 2. Now for k is equal to 3. Again, if you see, this element is 1, which is not equal to 2. Now you don't have to check this element, right? Because the range is k, which is equal to 3. So same you need to do for each and every element. And if you see, for 3 as well, for 4 and for 1 as well. Again, if you check for 2, then we don't have. If you check for 3, we don't have any duplicate element here as well. For 4, we don't have any duplicate element here as well, right? So the output is going to be false because we didn't get any duplicate element. Let's see the second given test cases we have. So the second test case is 1, 2, 3, 1, 4 and 5. Now again, k value is 3. So again, we are going to do the same thing. What we are going to do? First, we are going to check for 1, right? So for k is equal to 1, we will check 2. No, it is not equal to 1. We didn't get any duplicate element here. Let's check for other element. Again, we don't get any duplicate element here. Now, if you see, we get a duplicate element here, right? Because if you see, 1 is standing, we are standing here, and we need to check till 3 element, right? So for k is equal to 1, k is equal to 1, k is equal to 2, and k is equal to 3. So these are the 3 elements that we need to check. So we check for 2, 3, and 1, and we found here a duplicate element. So you don't have to explore the other element once you found a duplicate element, right? Because in the problem statement, if you see, it is asked that you need to check if array contains any duplicate element within k distance. So if you even found one element having duplicates within its range, then you don't have to go and you don't have to check for the other element, right? Because even if they have duplicates or not, doesn't matter. Our output is decided and output is going to be true only, right? So this is the test case we have. I hope you understood the question. Now let's try to understand the approach to solve this problem. So first of all, we will try to understand through the brute force approach. Okay. So let's see what we are going to do in brute force approach. What exactly we need to do? We are going to use a loop, right? As we have discussed, right? We have discussed, just a minute. So we have discussed that if we are standing at one element, we need to check the k other element, right? So if you are standing at this element, which let's say its value is I, right? I is equal to 0. Now you need to check I plus k element, which is I plus k is what? K value is 3. So I plus k is going to be 3. So you need to check till 1, 2 and 3. You need to check till this 4 element, right? So for this, we can simply use a loop. You can use any loop according to you. You can use for or while loop. Now, what you have to do, for each element I, check element from I plus 1 to I plus k. As I said, if this is our value where we are standing, this is the element where we are standing, then you need to check for I is equal to I plus 1 to I plus k, right? So I plus 1 from here, you need to check to I plus k till here, right? So that is what you need to do. And if any duplicate element found in this range, then return true. and exit from the execution. You don't have to execute further. Now, if you don't get any duplicate element, then go ahead and go check for element 2, right? Now, this I is equal to 1 here. You need to check from I is equal to 1 to I plus k, which is till here, right? For 2, we are going to check till here. So this is how we are going to proceed. And in this also, I have taken the same test case given in the question. So the output is going to be false. But what about the time and space complexity of this approach? So what do you think? If you see what exactly we are doing, we are standing at one point and then we are going and we are checking the k other elements we have, right? We are checking the k elements we have. So for one element, we are going and we are doing some k operations, right? So what do you think? How many elements we have in our array? In our array, we have n elements. So for n elements, we are going to check n into k operation. Okay, we are going to do this much of operation in worst case, right? So this is going to be our time complexity as well. So if I discuss, let me go down. So our time complexity for this approach is going to be big O of n into k, right? For as I explained, k is the operation that we are doing for each and every element of an array. So the size of the array is n. So we are going to do total n into k operations, right? And what about the space complexity? Since we are just using some loops and we are using some variables, which is not going to take any space other than the constant space, right? So the space complexity will remain big O of 1 only, right? Because we have not used any other space, extra space. So I hope you understood the brute force approach we have. And the code is going to be very simple. You are just going to use a loop and you need to start from I plus 1 and you need to check till k, right? And you need to do for each and every element. If you found any duplicate element, just return true from there. Otherwise, come out from the loop and then return false. Okay. Now let's see the optimized approach we have. So what basically we are going to do? We are going to use a hash set. Now why I have chosen a hash set here? Because we know that hash set performs all the operations in just big of one operation, right? So it is going to reduce our time complexity. So we can use hash set or you can use hash map as well. But here I don't need a value keys enough to solve this problem. So I'm using hash set. But still you can use hash map or any other data structure to solve this problem, right? So what exactly we are going to do with the help of hash set? Let's see. So first we are going to maintain a hash set of k elements. Now the last k element means I will explain you later while explaining the test cases. Now what we need to do, we need to check if our element which we are going to insert in our hash set, is it already present? If it is already present, then it means that it is a duplicate element we have and we need to return true. But if element is not present, we need to check for other element, right? Now what is the fifth point we have? If hash set size exceeds then k, then remove the oldest element, that is I minus k. What exactly it means? Let's try to understand. So I have taken one example here to make you understand better. So in this, what exactly I'm going to do? I'm going to create a hash set and we will try to perform the operations one by one. Okay. So first, if you see, this is my hash set. Now, initially my hash set is empty. My hash set is empty. I have not inserted anything in the hash set. Now, what I'm going to do, I'm going to start from the first element of the array. What I will do, I will take that element and I will insert it in our hash set. So let's say I inserted our 1 in our hash set, right? So now our hash set is looking like this. After I is equal to 1 or I is equal to 0, because since we are working with the array, so it's a zero based index. So for I is equal to 0, it means for element 1, what exactly we have in our hash set? I am going to denote hash set by h. Okay. So in our hash set, we are going to have only 1. Now first we will check if we have anything in our hash set. No, we don't have, since our hash set is empty. So we will insert 1 in our hash set. Okay. Now we will check the size of the hash set as well. Now the size of the hash set is 1 only, so we don't have to do anything, right? Now let's go and let's check for 2. So for I is equal to 2. For I is equal to 1, the element is 2. Now again we are going to do the same thing. First we will check if element 2 is present in the hash set or not. Since element 2 is not present in the hash set, so we are going to insert it in our hash set. So now in our hash set we have 2 elements, that is 1 and 2. Now let's check for the other element we have. Now if you see, we have now I value is 2, right? That is second index of the array. Now the element that we are talking about is 3. Now again we are going to check if element 3 is there in our hash set or not. So we don't have our element 3 in the hash set. So let's insert it in our hash set. This is also done. Now again we proceeded further and we found 1, right? Now this time i's value is 3 and the element is 1. So again we are going to check if element 1 is present in our hash set or not. So if you see element 1 is present in our hash set, it means we found one duplicate element within the range k. Now, what is within the range k here? So basically, if you see, we are having only 3 elements in the hash set. So we are maintaining only 3 elements in the hash set. Why we are maintaining only 3 elements in the hash set? Because k value is 3, right? Because k value is 3. So if we would have k value is equal to 4, then we would have inserted one more element. Let's say if this is not 1, if this is the element 4, then we have inserted one more element here, right? But if this is element 4 and the k value is 3 only, in that case, you will not insert 4 in the hash set. Otherwise, your hash set will have 4 elements that we don't want, right? That is unnecessary to store these 4 elements at the same time. Because k value is 3, so every time we need to have one, if we have one element, we need to check only 3 elements, up to 3 elements, right? So we don't need the 4th element. So let's focus on this test case first. Then we will try to understand using one more test case we have. So now, right now, since you have 1 in the hash set, so what you will do, you found the duplicate within the range k and you will return true from here. So your output is going to be true, right? Your output is going to be true for this test case. Let's try to understand this for one more, just to keep the explanation better, right? And so that you can also understand better. So let's see, for one more test case we have. So I'm going to use the same test case that we used here. That is 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, right? This is the element we have. So let's check for the same element. 1, 2, 3, 4, and 1, 2, 3, 4. So this is the array we have. Now what is the value of k here? So the value of k is equal to 3 only, right? So again, let's solve the problem with the help of hash set, right? So what exactly we are going to do? So this is our hash set, right? Right now our hash set is empty. Now let's see, let me write the indexes as well. So these are the indexes we have, 1, 2, 0, 1, 2, 3, 4, 5, 6, and 7, right? So for I is equal to 1. So for I is equal to 0, sorry, the element is 1, right? So what exactly we are going to do? We are going to insert this in our hash set. So we are going to insert 1 in our hash set. Now for I is equal to, now the element is 2, right? For index 1 element is 2. So again you will insert 1 in our hash set. So you will insert 2 in the hash set. The element is 2. So we are going to insert element 2 in our hash set. Now for I is equal to 2, that is the element. Which element is it? For I is equal to 2, we have the element 3. So again, we are going to insert this 3. So 1, 2, and 3 is going to be in our hash set, right? 1, 2, 3 is going to be in our hash set. Now this is the point where I wanted to explain you, and that is the reason I have taken another test case. Now for I is equal to 3, that is for the third index of the array, which is element 4. If you see, first we are going to check if this element 4 is in our hash set or not. So we don't have this, right? So what you are going to do, you are going to say, okay, what I will do, I will insert this 4 in the hash set. First, I will insert this 4 in our hash set, but now 1 is no longer needed, because if we are going to check for 4, like if we are going to check for other element, then we are going to check only the last 3 element, right? Because this is only the range we have that we need to check. So we don't need this element 1 now. So if you see, the size of our hash set has been exceeded the value k, which was equal to 3, right? Now the hash set size is 4. So we will remove the oldest element from the hash set. And which is the oldest element we have? So this is the oldest element we have. So we are going to remove 1 from the hash set. And now our hash set will have only 2, 3, 4, right? Only 2, 3, 4 elements remains in our hash set. Now you will again go and you will check for I is equal to 4th index, which is element 1, right? Which is element 1. Now again, in our hash set we have only 2, 3, 4. So first we will check if 1 is in the hash set or not. Now I hope you can understand from here, if we would have not removed this 1, then we would have found that this element 1 is already present in our hash set. And in that case, we would have returned true, that we found one duplicate element. But that is not true, right? Because we need to check only 3 elements, because key value is 3. So we don't have to check the 4 element, last 4 element, right? And that is the reason we have removed this 1. Now you will see that 1 is not present in the hash set. So what you will do, you will insert this 1 in the hash set, right? So your hash set will have now 2, 3, 4, and 1, right? Now again, if you see, we don't need this 2 now. Because whatever the x element we have that we are going to insert later, we are going to check only the 3 last element, not the 4 last element. So we don't need this 2. So again, we will remove this 2 and our hash set will have only 3, 4, and 1. Right? Similarly, you will keep doing this for each and every element once your I value exceeded the size k. So I hope you understand. I hope you understood the approach. Now let's see and let's try to understand with the help of code. Okay, so let's write code for this. Okay, so now we are going to write code for this. So first, as we have decided that we are going to use hash set for this code, right? So we are going to use hash set. So in our hash set, we are going to have only integer values, right? So that we have to mention that in our hash set, we are going to have integer value. My hash set name is essay, and we don't specify the size of the hash set here, right? That we have to maintain. Now you need to use a for loop, right? For traversing in each and every element. So starting from 0, I will go till whatever the length of the array is, I plus plus. Now what is the first step we have? So whenever we are having one element, we will first check if that element is present in the hash set or not, right? So first we will check if our HS contains that element. Which element we are talking about? Array of I. If it contains the element, it means we found the duplicate and we need to return true from here, and we don't have to do anything else, right? But what if element is not there? Now in that case, what we have decided that we will directly insert that element in the hash set if the element is not there, right? So we will insert, how we insert element? Using add function. So array of I. So we are inserting that element in the hash. Now we have inserted the element as well. Now what next? Now if you remember this, we are taking one element, we are checking if it is present in the hash set or not, and if it is not, we are inserting it. But don't forget to remove the oldest element, right? So that also we need to check. So now we need to take care if the size of our hash set exceeded the given range, right? So for that, I'm simply going to check if I value is greater than equal to k, then what exactly I'm going to do. So why I have written this condition, I is greater than equal to k. Let's see. So if you see here, for I is equal to 0 and I is equal to 1, I have not done anything. I have not removed any element. For I is equal to 3 as well, I have not removed any element, right? So till I is equal to 2, I have not removed any element. But for I is equal to 3, when I value is equal to k value, I started removing element. And for each I value, I started removing one element, right? So we need to do it for till the length of the array. But for the first k minus 1 element, we don't have to perform this operation, right? And that is the reason I have writing if I is greater than equal to k, then only we are going to do what? We are going to remove the oldest element in our hash set. And how we are going to find out? So we just need to remove array of I minus k. Now k is the value, right? Let's see. Now if you see, this element is the 0th index element, right? And we know in hash set, the elements are in proper order, right? So this 0th, so right now our I value is 3. So we are going to remove I minus 3. I minus k value, which is 0th index element. So this 0th index element will be removed, which is 1, right? So that is what we want. So I am writing I minus k. That's it. And if we survive the whole for loop, it means that we didn't get any duplicate element and we need to remove, we need to return false. So now let's see if the code is working fine. Okay, so see, the compilation seems good. Let's submit the code and let's see. So all the test cases are passing, right? What about the time and space complexity we have? So we have not discussed about it. Let's see. So as you can see, right, we are traversing this time. We are not doing k operation for each element, right? So right now our time complexity is big of n only because we are traversing in the whole array. What about the insertion, removal, time complexity in the hash set? So we know that in hash set, this cost us big of 1 only. So this will not impact our overall time complexity. So the time complexity is big of n only. And what about the space complexity we have? So the space complexity is going to be big of n. The thing is that we are going to, I admit that we are going to store k element at max, right? But what if our k value, array length is 5 and k value is 4? So in the worst case, we are going to store, or in this case, I can say we are going to store 5 elements before the removal of the oldest element. So that is the reason the max space complexity is going to be big of n. So I hope you understood the whole problem statement and the solution that we have discussed. Thank you for watching the video.